solve this problem about electric circuits, we need to identify our given values. So we have an EMF which is equal to 350 times e raised to negative 20t, and a resistance of 10 ohms, and a capacitance of 0.005 farad. So to solve this problem, we need our equation, which is E equals to E sub R plus E sub C. And since we don't have the given current and we don't have an inductor, this will be our next equation. E equals to dq over dt times R plus Q over C. And the next step would be to substitute all of these given values to this equation and then simplify it and rearrange it so that it will become a linear D, wherein our independent variable is T and our dependent variable is Q. So this is the formula to solve for this linear DE. So once we simplify this equation or this formula and integrate everything, we will get Q times E raised to 20t equals to 35t plus C. So we don't have a C. So to get for C, you just substitute t equals 0 and q equals 0 to this equation, and then we will get a C which is equal to 0. And after simplifying everything and substituting the C to this equation, we will get the equation for the charge at any time, which is equal to 35t times e raised to negative 20t, and this is our equation 1. So to get for the maximum charge, we just find the first derivative of the equation 1 and equate it to 0, and therefore our time is equal to 1.43 times 10 raised to negative 3 seconds. And to get for the maximum charge, we substitute this time to equation 1, and we will get a charge of 0.0486 coulombs. So for this problem, we also need to solve for the current when the charge is at maximum. So we need to use this equation, E equals to IR plus Q over C. And since we already have the EMF, the resistance and the charge and the capacitance, what we need to do next is just substitute all our values, and we will get an I, or a current of 33.04 amperes. And so this is how we solve our problem.